Dear students, I welcome you all to the lecture series on course material of Transportation Engineering 2. In this course, in the previous lecture, we have discussed about the history of Indian Railways, and we have also seen the administrative setup of Indian Railways. In today's lecture, we will be giving a focus on the different types of the gauges, their associated features, and the permanent way. In this lecture, we will be discussing gauges, the gauge classification on Indian Railways, the problems of multi-gauge system, the uni-gauge policy of Indian Railways, specific gauges, and the permanent way. Now we will be starting with the gauges and gauge classifications adopted on Indian Railways. The gauges, as we see in this diagram shows us a rail wherein the head of the rail and the foot of the rail has been shown, and the two rails have been placed parallel to each other. The clear distance between the head of these two rails is defined as gauge. Therefore, the definition of the gauge will be, it's the clear distance between two parallel rails laid in any track. So, with this definition, we will try to look at what are the different distances or the clear dimensions which have been provided between the two rail sections or the heads of the rail sections by which we can classify the various gauges. When we look at this classification, what we found is that there are different gauges which are available throughout the world. We have gauges like standard gauges. In the case of standard gauges, the clear distance between the two rail sections is 1435 mm. And these standard gauges, they are available throughout the world on an average about 62% of the countries or the gauges which have been provided in the world, they are standard gauges. The other category is broad gauge. In the case of broad gauge, the clear dimensions are 1676 mm or it is 1524 mm. On an average, throughout the world, the share of broad gauge is 15%. When we look at some of the countries in which the standard gauges have been provided, we found that they have been provided in United Kingdom, United States of America, Canada, Turkey, and China. These are the major countries in which the standard gauges have been provided, though there are some other countries too where these gauges are being provided. In the case of broad gauge, it is being provided mostly in the Indian subcontinent or some other developing countries like in India, Pakistan, Sri Lanka, Brazil, Argentina, and Russia again are the major countries in which the broad gauge has been provided. Other than the standard gauge and the broad gauge, there is another category which is known as Cape gauge, where the dimensions or the clear distance between the rail sections is 1067 mm, and it constitutes around 8% of the total gauges which have been provided throughout the world. Other than the Cape gauge, there is a meter gauge where the clear distance between the rail sections remains as 1000 mm, and in this case, the share of meter gauge throughout the world worldwide is around 9%. We can say it's very similar to somewhere around 8% of the Cape gauge. Other than these four major gauges which have been provided throughout the world, there are 23 other gauges which have been used in different countries of the world. Again, looking at the different countries in which these gauges have been provided, we found that the Cape gauge has been provided in Africa, Japan, Australia, New Zealand. The meter gauge again in India, France, Argentina, Switzerland, and then there are a number of other countries in which the other gauges have been provided. So these are the different gauges which are provided through different countries, and what we found is that out of all these gauges, some of the gauges have been provided in our country, that is in India. So we will try to look at the gauges which have been provided in India. In India, we have provided broad gauge. The broad gauge is being provided on 63% of the route kilometers, and the clear dimensions which have been taken between the rail sections, they are 1676 mm. Now the clear dimension which is being adopted in some of the countries like 1524 mm is not being adopted in India. Then another gauge which is used in India is meter gauge. In the case of meter gauge, the distance between the two rail sections, or the clear distance, is 1000 mm, and this has been provided in 31% of the route kilometers provided throughout the railway network in India. Then there is another gauge which is termed as narrow gauge. There is a specific gauge which is provided in very specific areas in our country, and the clear dimensions in this case, they remain at 762 mm or 610 mm, and it constitutes around 6% of the route kilometers. These narrow gauges, as we found, as they are being provided in mostly the hilly areas where the terrain are such that we cannot go for the bigger gauges like meter gauges or broad gauges. Now the question comes, how we are going to select a gauge, whether we should provide a broad gauge in any area, or we should provide a meter gauge, or we should go for a narrow gauge or a hill gauge, that is 610 mm gauge. There are certain factors which needs to be considered. The first factor which needs to be considered is the cost of construction. Of course, whatever decisions we take, the very first factor which comes into consideration is the cost. The cost of the gauge or the provision of the gauge needs to be checked in terms of different components. It is to be checked in terms of the total amount of the area which is to be acquired. It is to be talked in terms of the different other components of the construction, or it is to be talked in terms of the earthwork involved in constructing a broad gauge or a meter gauge or a narrow gauge. Similarly, there is another factor is some specific features which needs to be provided on any track. One such feature like is bridges. So we have to look at the cost of the construction of bridges also. Then there is a cost associated with the buildings, the cost associated with the platforms or the physical features which needs to be provided at a terminal building or a junction building or any intermediate station. There is a cost which is involved in the controlling features like signals. Then there is a cost associated with the rolling stock, that is the things which are moving on the track. So when we are looking at different cost of constructions, what we found is that all the components which we have just discussed now, they are not having the similar effect. If we are moving from say narrow gauge to meter gauge, or we are moving from meter gauge to broad gauge construction, then what we found is that if we are taking a component like land or earthwork, then there is going to be a proportional increase in the cost of construction as we shift from a lower gauge to the higher gauge. Whereas if we are talking about the bridges or the similar type of structures, then there is a marginal increase in the cost. It's not proportional. In the case of the buildings or signals, because these are the assets, these are the features which needs to be provided whatever gauge we are using, therefore there is no effect of the cost of building or signals in terms of the provision of a narrow gauge or a meter gauge or a broad gauge, or changing from a narrow gauge to meter gauge, or from changing from a meter gauge to broad gauge. In the case of rolling stock, mostly we have to take it independently of the cost of the construction, because there are specific features or specifications which are associated with the meter gauge or the narrow gauge or the broad gauge, and therefore that cannot be considered in this component. Similarly, there is another factor which needs to be considered when we have to discuss about the provision of a gauge, that is physical features of the country. This is another important feature, because we have to look at the capacity, we have to look at the different specifications which are associated with the construction of that gauge. If we are looking at the broad gauge where the wider section has been provided, or if we are looking at a narrow gauge where a very narrow section has been provided with respect to the broad gauge, then the total amount of specifications or the type of specifications, they also remain in the same context. In that sense, if we look at some of the specific features, physical features of the country like gradients, then we have to look at that whether it's feasible to provide a broad gauge or it's feasible to provide a narrow gauge so as to traverse a gradient which is provided in any hilly or mountainous area. Probably that's the reason that we have provided narrow gauges or hill gauges in very specific locations like Ooty, Darjeeling, etc. There is another specific feature, a physical feature, that is curves. When a rolling stock is moving on any of the track of any specification, maybe broad gauge, meter gauge or narrow gauge, then we have to look at the ease with which a movement can be made. And this movement is going to be controlled by the total amount of resistances or the total amount of forces which are acting on that track or the rolling stock. Looking at that aspect, there is again some limitations with respect to the curves. So it means we have to look at the gradients, the curves, or similarly some other physical features of the country, and then on the basis of that we should decide whether we can go for the construction of a broad gauge or a meter gauge or a narrow gauge. What we found is that if we are having a steep gradients or there are very extensive curves, narrow curves are being provided, then it's better to go for narrow gauge instead of the broad gauge or the meter gauge. But if the gradients are quite feasible or the curves are having a large radius, that is they are much of flatter curves, in that sense we can go for broad gauge constructions. This is the example which has been given here. This hill railways like from Kalka to Shimla, as you must have seen or you must have heard about, or probably some of you have also gone through the experience of moving from Kalka to Shimla by a train, and that's the hill railways. Similarly, there is another railway which is being provided with the Darjeeling area. You have to go from Siliguri to Darjeeling, and that's another scenic beauty area where we have the heritage rail section is still working or the locomotive is still working. Then the third area, the hill railways, is the Ooty area. So all these are specific areas where the hill gauge or the narrow gauge has been provided with some further specific features. Probably we will be discussing where we will be taking up the alignments of the rail sections. Then the next factor which is there, which controls the selection of the gauge, is traffic. What is the total amount of traffic which is going to traverse, which is going to use that facility? What is the nature of that traffic? We have to look at all these aspects. Unless until we look on all these aspects, we cannot decide whether we can go for a broad gauge construction or a meter gauge construction. If there is no traffic at all or there is very small traffic available, then if we are incurring a cost equivalent to the broad gauge construction, that's going to be something like a useless thing, or it will be an extra expenditure which is being incurred on the provision of that facility. So that's why there is a judicious requirement of thinking about what type of gauge can be provided with respect to the traffic which will be there or which will going to use that facility. Now in this case, if we found that there is a very heavy traffic, a large number of trips are going to be made by the railways, then we can go for a wider gauge, that is the broad gauge. Similarly, the another condition is that if there is a high volume, large amount of traffic is going to be there, large number of persons are going to use the facility, or there are chances that the commodities are going to be ferried through the railway systems, that the freight transportation has a potential in that area. In that case, we again can go for the broad gauge construction. But if the volumes are lower, then we can go for a smaller gauges too. Another aspect is the speed. In the case of the broad gauge, as the size or the diameter of the wheel increases, in that case what happens is that the total circumferential area distance which can be moved by that wheel also increases, and therefore the speed of the vehicle will increase in the case of a higher gauge. That's why if we are interested in achieving higher speeds, we can go for broad gauges instead of the narrow gauges or the meter gauges. In this case again, the traction or signaling, they are independent things. Signaling is one of the aspect which controls or provides the safety on the track. Now, whatever are the speeds, it's not going to be controlled by the speed. It is going to define the things in terms of the movements going on any of the tracks so as to reduce the chances of any accident taking place because of the unidirectional traffic or the bidirectional traffic. Similarly is the case in our traction. Traction means the total amount of tractive effort which is available with any locomotive which needs to be provided on the basis of the traffic. If there is a higher traffic, obviously we are going for the broad gauge construction, and then for those broad gauge constructions we have specific locomotives which can be used. Similarly, if we are talking about the meter gauge construction, then again we have the specific locomotives which can be used for the meter gauge construction. Therefore, the things are quite independent as far as the traffic is concerned. Then another aspect is that if we are going for a wider gauge, it means we can haul large amount of persons, or we can haul a large amount of freight between the origin or destination. In that sense, the total operating cost per ton kilometer will reduce. So that's another operational advantage which will be there in case we shift from a lower gauge to a higher gauge. So in this sense, there are so many factors which are interlinked with each other, and therefore we have to take all of these together into consideration, and then only we can decide that what type of gauge can be provided. It's not a single factor decision which can be taken as such. Now, on the basis of all these, there is a certain classification which has been adopted in Indian Railways regarding all the types of the tracks or the gauges which can be provided. In the case of the broad gauge track classification, we have different groups like A, B, C, D and E, and for all these groups there are certain features or specifications which needs to be complied with. Now, in these further slides we will be looking at these groups of the broad gauge track classification and the specific features related to them. Here in this slide we are taking the specifications related to group A and group B of the broad gauge track classification. In this case of the broad gauge track classification of this one, the speeds are controlled up to 160 km per hour in the case of A category of broad gauge, whereas in the case of B category of broad gauge the speeds are controlled or limited up to 130 km per hour. Another aspect is the type of the rail section which can be used. This type of the rail section is defined in terms of the kg weight per meter length of the rail section. That's one specific unit which is being adopted in Indian Railways or in other railways too, depending on the units in which they are working. So we have to look at this aspect, and this is defined in terms of the total amount of traffic which can be hauled. In this case, the classification of this total amount of traffic is being done in three categories. We have the traffic less than 10 GMT, then another category is from 10 to 20 GMT, and the third category is greater than 20 GMT. For all these categories, the section of the rail has been defined in terms of the weight per meter rail length, and that is being taken as 60 kg per meter in the case of traffic load which is more than 20 GMT for both the cases of category A and category B of the broad gauge track classification, whereas it is being taken as 52 kg per meter rail section length in terms of the two other categories of the traffic, that is 10 to 20 GMT and less than 10 GMT in both the cases of category A and category B broad gauge track classification. Further, in the case of another two categories, that is category C and category D of the broad gauge classification, what we look is that the speeds are being restricted in the case of category C to suburban railway conditions. These suburban railway conditions are synonymous to the rail conditions or the local trains which have been provided in Bombay, or the metro trains being provided in Kolkata or Delhi, or again another ring railway which is being provided in Madras or Chennai. In the case of the D category of the broad gauge track classification, the speeds are restricted to 100 kilometers per hour. The type of the rail section, again in kg per meter section weight, it is being defined for the rest of the three categories, that is greater than 20 GMT, 10 to 20 GMT and less than 10 GMT. In this case too, what we found is that the rail section is being used as 60 kg per meter rail section for the traffic load of greater than 20 GMT in both the cases of C and D category of broad gauge track classification. Whereas in the rest of the two categories, that is from 10 to 20 GMT and less than 10 GMT, for both the categories of C and D broad gauge track classification conditions, the type of the rail section used is 52 kg per meter length. Again, coming back to the A and B category, we will look at some other specifications which are associated with these tracks. They are sleeper density. Sleeper density is a term where it is defined as the total number of sleepers which needs to be provided per kilometer length of the rail section or the track. So if we have laid 1 kilometer length of the track or the rails, then how many sleepers we are going to provide below the rail. That is what is termed as sleeper density. And this sleeper density in the case of category A broad gauge track classification is 1660 sleepers. It means 1660 sleepers needs to be provided in 1 kilometer rail length in the case of the A category of broad gauge track classification. Whereas in the case of B category of broad gauge track classification, we have either or two conditions, that is we can go for 16660 sleeper density or we can go for 1540 number of sleepers per kilometer length of the track. Another aspect is the ballast cushion. Ballast cushion is defined in terms of the total depth of the ballast which is provided below the sleepers. So this ballast which is provided below the sleepers is 300 mm depth in case of A category of broad gauge track classification, whereas in the case of B category of broad gauge track classification, it is either 300 mm or 250 mm. Again, coming back to C and D category of the broad track classifications, we are looking back on the same aspects or the specifications which we have seen for A and B categories just in the previous slide. Here what we found is that in the case of the C category, which is related to the suburban railways, or in the case of D category, we have the similar conditions of the sleeper density in terms of total number of sleepers per kilometer track length, that is 16660 or 1540 sleepers per kilometer length. In case of the ballast cushion, the values are again in the case of C it is 300 mm and in the case of D category it is 300 mm or 250 mm. Now coming to the last group in the broad gauge track classification category, that is group E, we found that the speeds are less than 100 kilometers per hour. The rail section in kg per meter in the terms of traffic which is greater than 20 GMT, there are generally not the cases where the traffic is going to be more than 20 GMT in the case of E category of broad gauge track classifications. In the category of 10 to 20 GMT, we are using 52 kg per meter rail section, that is the length for per meter rail length of the section, the weight of the rail section is 52 kg. And then in the case of less than 10 GMT, the rail section which we are using is another specific rail section which is defined as 52 SS section. The sleeper density again in terms of numbers per kilometer rail length is 1540 to 1310. These are the two values which can be used in the case of the group E or category E of the broad gauge track classification. And the ballast cushion ranges from 300 mm to 200 mm. In that sense, what we found is that we are having certain ranges for the speed, for the rail sections, for the sleeper densities and for the ballast cushion. The speed is changing from somewhere around 100 kilometers per hour to 160 kilometers per hour. The rail sections are varying from 52 SS to 52 to 60 kg per meter. the sleeper density is varying from 1310 to 1540 to 1640, and the ballast cushion is varying from 200 to 250 to 300 mm. So this is how the specifications of the broad gauge tracks are varying for the 5 categories which we have seen just now. Now further things are that the rails which are to be used from group A to group D, they should be 90 UTS rail. 90 UTS rails means this is UTS is ultimate tensile strength and the units are kg per mm square. So it means the rail sections which we are using for the categories group A to category group D, they should have ultimate tensile strength of 90 kg per mm square. That's how they are being defined. There is another category of rail sections which are being used in Indian Railways, that is 72 UTS rail section. Then the sleepers, they should be generally of concrete, or there is another category of rail sleepers which is CST 9 sleeper. So we will be looking at this type of the sleepers, the concrete sleepers or the CST 9 sleepers, when the sleepers will be taken up through the lecture series of Transportation Engineering 2. Now here we are going to look at certain tracks which have been defined under the different groups of broad gauge, that is group A, B, C, D and E. In the case of group A, there are 5 sections which have been defined under this category. The one section is New Delhi Howrah, another section is New Delhi to Mumbai Central, then another section is the New Delhi to Madras Central, then Howrah to Mumbai UAT, and the new section which was added some time back was Ratnagiri to Sawantwadi, that is on Konkan Railways. That's why it is termed as KR here. Then in the case of group B, we have 25 such rail sections. They are Allahabad to Bhusawal via Jabalpur, Kalyan to Kajipet via Dondwadi and Pune, Vadodara to Ahmedabad, Mathura to Ratlam, then Sitarampur to Mughalsarai via Patna, Howrah to Vardhman via Bandel, Kharagpur to Vijayawada via Voltaire, Kale to Badhawa via Sahibganj, Delhi to Kalka via Ambala Kent, Ambala Kent to Pathankot via Ludhiana, Ambala Kent to Mughalsarai via Muradabad, Lucknow and Pratapgarh. Then there is another section from Agra Kent to Lalitpur, Lucknow to Kanpur, Virar to Godara, Lalitpur to Bina, Khanna to Malda town via Farakka, Wadi to Madras Central via Raichur, Jolarpettai to Bangalore, Arakonam to Ernakulam via Erode Coimbatore, New Jalpaiguri to Malda town, that is the North Frontier Railway, Chennai Beach to Dindigul, Chennai Beach to Chennai Agmore, Bangalore to Booty, Ghaziabad to Saharanpur. Some more are like Ahmedabad to Delhi via Bandikoi, Kanpur to Agra. So these are the broad gauge track classifications which are there. In the case of group C, we have not gone for the group C conditions because they are the suburban railways, as I have just discussed in the previous slides, that they belongs to the local trains which are suburban railways or local trains moving in Mumbai, Kolkata, Delhi, Madras and likewise. Now we come to the group D. In the case of group D, there are 38 rail sections which have been classified into this category. Similarly, in group E, there are more than 38 rail sections which have been categorized in this one, and we are not going into the details of all these rail sections now because of the lack of time. Now we move to the meter gauge track classification. In the case of meter gauge track classification, we have 3 categories of the track classifications. The first classification category is the Q routes, whereas the speeds are more than 75 kilometers per hour and the traffic density is defined in terms of more than 2.5 GMT. In this case, some of the examples are Rewari Ringas Fulera, Ratnagar to Degana, Delhi Sarai Rohilla to Ratangarh, Ajmer to Khandwa, then Jaipur to Ajmer, Ahmedabad to Bhavnagar, Agra to Lal Kuan via Bhojipura Mathura, Bhojipura to Lucknow Junction, Vilupuram to Tiruchinappalli via Tanjavur, Chennai Beach to Velipuram, Dandigal to Madurai, Jodhpur to Agra East Bank via Jaipur, Kathgodam to Bhojipur, Bangalore to Miraj. Another category in the case of meter gauge track classification is R routes. In this case, the tracks have the potential of moving the trains at a speed of 75 kilometers per hour, but they are not moving the trains at this speed, but if required, that can be done. In the case of the traffic density, it is a little lower than the previous category, that is the Q routes. Here it is 1.5 GMT or more. In this case, we have again some categories like R1 route, where it is defined as greater than 5 GMT per year, and these are some of the routes which are there, like Hospet Hubli, Sikandrabad to Guntkul, Londa to Marmagoa, Katihar to New Bombaigaon, Guwahati to Tinsukia, Gandhinagar to Palampur, or so on. Coming to the next category under the R routes is the R2 routes, where the traffic density or intensity has been defined in terms of 2.5 to 5 GMT per year. Some examples of the routes here are Guntkal to Hospet, Guntkal to Velipuram, Tiruchinappalli to Madurai, Virodhanagar, Purna Secunderabad, Jodhpur, Marwa. Now we will look up at the another meter gauge track classification. Here again, in the case of the route R category, we have the third category R3 routes, where the traffic intensity is being defined in terms of 1.5 to 2.5 GMT per year. And in this case again, there are certain examples which have been given for the tracks. The Madurai Rameshwaram section, Virodhanagar Tenkasi section, Dindigul Polachi, Ratangarh Bikaner Mehta Road, Muzaffarpur Narkatiyaganj, and Virur Shimoga town. They are some of the sections of the railways or rail tracks which fall under R3 route category. Then there is another category which is termed as S class, where all the remaining meter gauge lines which are rated for below 75 kilometers per hour and or with low traffic densities, that is generally below 1.5 GMT per year, they fall under this category. So they are all meter gauge track classifications. Now coming to the Indian Railways track specifications on the basis of whatever tracks we have seen so far. The very first specification is the permissible degree of curvature, that is the amount of the angle which is being fall on the center of the curve by a specified length of the chord. In the case of the broad gauge, this is defined as 10 degrees, that is the maximum value of the degree of curvature which can be provided on any broad gauge track. In the case of the meter gauge, it is 16 degrees, and in the case of the narrow gauge, it is 40 degrees. So these are permissible values which needs to be provided for the Indian Railway tracks. In the case of the ballast cushion, as we have seen previously, it varies from 20 to 30 centimeter thickness, that is 200 to 300 mm thickness, as we have written or we have seen in the previous slides. The sleeper density here is being defined in another notation, that is m plus 7 to m plus 4, though it is also being defined here in terms of those similar notations which we have discussed previously under the categories of broad gauge track classifications, moving from category A to category E. In that categorization, we have seen that the value of the sleeper density was changing from 1310 per kilometer to 1660 per kilometer, with the intermediate value of 1540 per kilometer. Here there is another way of defining the same thing in terms of a factor or a value defined as m plus 7 to m plus 4. With 7 or 4, they are the arbitrary values being taken, so it can be 4, 5, 6 or 7. And m is defined as the length of the rail section manufactured at any of the company. So if there is a 12-meter rail section, it means it will transform to 12 plus 7 means 19, or 12 plus 4 means 16. So that's the range in which the sleeper density can be there for that rail section. If there is a heavier load, we go for the more of the sleepers to be provided within the rail sections. If there is a lesser of the load, then we go towards the lower value. So both are the ways by which we define generally the sleeper density. Of course, we will be looking at this aspect of sleeper density when we will be discussing sleepers in detail in some of the other lectures. Then another specification related to the interrailway tracks is regarding type of the sleepers which can be provided. They are pre-stressed concrete sleepers, especially for group A and group B routes, that is the high speed routes as far as the prevailing conditions are concerned. Though slowly and slowly we will be moving towards the speeds to as high as 250 to 300 kilometers per hour, and we are trying to find out the feasibility of providing those things or the changes to be made in the track specifications so that we can accommodate or provide the operational speed of that much range. In the case of the standard rails, we have to provide, in the case of the broad gauge, the rail section as 60 kg or 52 kg. When we say 60 kg or 52 kg, it means we are talking in terms of per meter rail length. Then in the case of the meter gauge, there are three categories of the standard rail sections which are provided. They are different than the rail sections which we have discussed so far. There are 90R rail section, 75R rail section and 60R rail section. This 95R, 75R or 60R rail section, they have been borrowed from the British railway standards. British were the people who started the railways in India, and therefore the standards were also borrowed from there. In this case, when we are talking about 90R, it means we are talking about 90 pound per yard rail length. Similarly, it is for 75 and 60R rail section. The length of the rail, it is either 13 meter in the case of the broad gauge or 12 meter in case of the meter gauge. This is the round off value of the actual lengths which are manufactured in the different companies who are manufacturing the rail sections. Another important thing is the fastenings which needs to be provided. Fastenings means those things which are used to connect the different rail sections with each other or the rail sections with the sleepers. These fastenings should be elastic in nature, and that is, as far as possible we should use those fastenings where the elasticity is being maintained. Then the other specific feature of tracks is turnouts. Turnout is a condition where we can change the direction from one track to the other track. Of course, we will be taking up turnouts again in details in some of the lectures. Here we are looking at just the main specification related to turnout. It is defined in terms of 1 in n value, where n can be anything, like it is 8.5 in the case of the movement of goods train. In the case of passenger trains, it varies from 1 in 12 to 1 in 16. As the value keeps on increasing, it means we are providing more flatter curve as compared to the sharper curve. It means there is a ease of turning and there is a comfort being maintained. And because in the case of the passenger movement, more comfort or ease or safety needs to be maintained, therefore that's why we have 1 in 12 or 1 in 16 sort of turnouts. Again, when we are going for high speeds, as I told you, we are trying to achieve the speeds to as high as 250 to 300 kilometers per hour. We will be looking at the turnouts which will be having the values of something like 1 in 20 or 1 in 24. Again, they are under considerations, and as soon as the things will be finalized, we will be knowing these aspects. Now we come to another aspect of the provision of the tracks or the gauges. That's a multi-gauge. And what is the problem associated with that multi-gauge system? As you have seen in the case of the Indian Railways, we are providing broad gauges, we are providing meter gauges, and then we have narrow gauges of two specifications, that is 760 and 610 mm. Is there any problem of providing so many gauges or shifting from one gauge to the other gauge? We can understand this problem when we keep ourselves into that condition. We assume that we have to go from say point A to point B, and there is an intermediate stop at point C where the change from one gauge to the other gauge has to be done. In that case, if you are traveling yourself in that sense, then what are the different problems you can foresee or you can experience? We will be looking at these problems which can be there. The very first thing is the inconvenience to the passengers. In this case, what are the different types of inconveniences which can be there? The one inconvenience is that because the specifications are different, therefore the tracks are provided at different locations for the meter gauge or for the broad gauge or for the narrow gauge. So if you are coming by a broad gauge train and you have to take a narrow gauge train or a meter gauge train, it means you have to go to some other platform. That's a change of the platform is necessary. So you have to take everything with you and move towards that side. That means either you have to cross the bridges or climb the bridges. That's another problem of associated with the change in the gauge. So you have to carry out with all the luggages with yourself, or you have to look for some manpower who can take all your luggage and you can move to the other gauge or the platform. So these are all types of inconveniences which will be there to any of the passenger when this type of changeover needs to be made or the transfer needs to be made. The hauling of luggage, the tensions regarding catching the link train, that's another important aspect. You don't know whether you are moving on the right time or you are going to be late, and therefore if there is a link train for that journey, then if you are going in the right time you can catch that one, otherwise you are going to miss it. So that sort of a tension will always remain with you. And the other big aspect is that if you are reaching that transfer point, that is station C, as we have taken an example, then if it is at the night time, the transfer at the night time is another very important and considerable thing, because there is safety is associated at that point of a time. So that's another sort of an inconvenience to the passengers. They have to stay awake or somebody has to waken them, and then only they can go and change over. Another aspect related to the multi-gauge is the transshipment of goods. Again, in this case there can be number of types of problems which may be associated with it, like there is a damage to goods. You have to take your goods from one point to the other point. There are always chances that something may get damaged. If you have booked your luggage, then it is to be transferred from one luggage van to the other luggage van, and during that time again there are chances of getting the things damaged. There are chances of theft also. You are transferring the things and somehow at some point of a time on a bad day you found that something is being lost. It is being theft. Or storage facilities are required in some of the cases. There is a large shipment which is going on, and in that case of a large shipment, when it is to be transferred by some other train of another gauge, then you have to put that material at some place. You have to store it. So storage facilities needs to be provided at that transfer point. Delays are caused many of times. These are the other aspect associated with it. Mishandling. Mishandling is again another specific case related to goods only. That is, instead of going to place B, the things are going to place D because of just a mishandling case. Then there is an inefficient use of the rolling stock. The inefficient use of the rolling stock means that whatever the total locomotives which are in use, we are not using them to the complete efficiency. The complete 100% utilization is not there. As we have taken an example that you are coming up to point C by the broad gauge, and then after that you are probably going by meter gauge or a narrow gauge, then in that sense whatever locomotive or the train or the compartments have come up to point C on a broad gauge, they will remain as such if they are not going to be moved to some other place. If they are moving to some other place, then it's okay, then they are under use and therefore there is no inefficiency involved with the use of the rolling stock. But if they have to stay there and they have to wait for another link train which comes, and then they will be taking that passenger traffic or the goods traffic and move back, in that sense that's an inefficient use of the rolling stock. So in that case, what may happen is that if we are interested in not having inefficient use and we think that we can transfer our train back to the origin point, then in that case it will be moving empty. That's another sort of inefficient use of the rolling stock, because we are not earning revenue. Now another case is that we are having the track which is lying idle for a long period of time because we are waiting for the traffic to come from the link line. If this is the case, then this is also termed as the inefficient use of the rolling stock. Then the transferability of equipment is not possible because they are of the different specifications. So because of this difference in specifications, we cannot make use of one thing at some other location. It has to be used where they are. So it means they will keep lying as such, and we are not in a position to use them efficiently. Another factor associated with the multi-gauge problem is the additional facilities which needs to be provided at stations or in the yards. We have to provide the sheds of different specifications. We have to provide the yards of different specifications because the different type of rolling stock is going to be there in that at that station. Then the maintenance equipment, again they are different from different types of the rolling stock, so we have to have all those type of maintenance equipments. Waiting rooms or areas, because the different platforms are associated, therefore we require waiting room on this platform as well as on the other platform, that is for a platform of broad gauge or a platform for the gauge other than the broad gauge. The platforms are also of different specifications because of the size differences or the specification differences in the meter gauge and the broad gauge, or the rolling stock specification differences. Then there is a factor that is hindrance to fast movement of goods and passenger traffic. You cannot move the things at a faster speed because it needs to be transferred at an intermediate point. When you are transferring the things at an intermediate point, then it means there will be some time lag which will be associated with that transfer, and therefore that's a hindrance. And it's a big problem, especially during emergencies. If there is an emergency and there is a big shipment which needs to be transferred or transported to that location, and if in between there is a transfer associated, then that cannot be done at a faster rate or a speedier rate. The delays associated with those transshipments are another reason. Another aspect here is the difficulty in the balanced economic growth. Now this is the aspect of the provision of the different types of the gauges in different areas, because our total resources gets distributed, and when the total resources are getting distributed, it can become a hindrance to the different types of the developments which can take place in any of area. Like there is an industrial development, there is a heavy industry which is to be placed in any area, then it will be requiring a broad gauge. But if the heavy industry is not there, then probably we can go for another gauge. But in that sense, there will be a multi-gauge problem, that you cannot transfer the one thing from the one point to the other point, and there is a efficiency involved with the industrial processes also, so it will be lost. Then movement between the points of production and consumption is another aspect in the case of the economic conditions. How much time it is going to take to move the things from the point of production to the place where the things are going to be consumed. That's another important aspect. Now difficulty in the future gauge conversion. This is next aspect. That's a problem in the case of the multi-gauge system, because if you are going to change over from the meter gauge or the narrow gauge to the broad gauge, then again the resources are involved in that one, and when the number of resources are involved in that one, you have to get all those resources, you have to take out the things, you have to suspend the movements, and that's the type of the difficulty which will be there in that aspect. Now we come to the related aspect of this one, that is uni-gauge policy. Looking at all those problems which are being faced by the freight movements or the passenger movements because of multi-gauge systems, the Indian Railways of the Government of India in 1992 decided to provide uniform gauges throughout the country, and therefore they came out with the uni-gauge policy. In this uni-gauge policy, there are certain advantages involved which are just the reverse of all those problems which we have seen previously. Like, there is no transport bottleneck. In this case, there is no need of transshipment because we are going from point A to point B in example which we have taken previously without stopping at point C or without changing the things at point C. No waiting and delays are associated here. The elimination of inconveniences because you are not going to come out at point C with all your luggages and you are moving. Handling of luggage is easier because it's to be placed once, to be taken out once. There is no transshipment hazard, that is, the safety is involved with the material. There is a better safety. There is no damage, no theft, no mishandling of luggage because nothing is going to be transferred from one compartment to the other compartment or one wagon to the other wagon or one platform to the other platform. There is elimination of unsafe nighttime transfers. Then there is another better aspect of unigauge policy is that we can think of provision of alternate routes, which was not possible in the previous conditions because all the resources was getting consumed in the provision of different type of facilities, different type of gauges throughout the country. Now we can think of that if there is one route, whether there is a possibility of providing any alternate route of the same specification so that the total load or the traffic can be diverted between those 2 points by using the alternate routes, or we can develop any other area and there can be a more of the development in that area, maybe industrial development or the employment generation likewise. So here we are looking at the pressure on the existing network will reduce, economic scenario will improve, higher penetration of products will be there because we are reaching different sections which we could not reach in the previous conditions. And there is a more flexibility of movement because we have the rolling stock available to us and we can use that rolling stock without changeovers. And there is a better connectivity. That's because the alternate routes are feasible things. There is also improved utilization of track. There is a more efficiency associated here. The higher efficiency will be there. There is a reduction in the operating expenses because we are not stopping at one point, we are achieving the things at higher speeds and there is a more of the efficiency involved. That's why the operating expenses are going down. There is less or no idling situation. Better turnaround condition because the rolling stock has not to wait at the intermediate or transfer point for the link traffic to come. Therefore, in that sense, the things can just change or take a turn from the next point to the previous point. The high use of the equipment will be there in this case. The operational expenses again will reduce. More operations can be scheduled because we are having a better turnaround time, no idling or delays are involved here. Higher benefits to the users because they are getting the facilities again and again at a lower time periods. There is an optimization of facilities because we are not required to provide the facilities at different locations, so you can optimize the things, locate them centrally or locate them specifically depending on the situations. There is better balanced economic growth, and in this case we have the regional effects will reduce because there is a greater connectivity from one part of the country to the other part of the country, and that's what we have seen in the independence condition of India also, where the railways were provided and they provided the connectivity to all of the different parts of the country. There is a higher growth of areas otherwise which are being left unconnected. That's another economic aspect of unigauge policy. More dispersal of activities will be there because there is no concentration of activities in one area. We have the correct connectivities. People start thinking of starting the different activities in different sections or different areas so that they can achieve better economic balanced growth. Then the next aspect is the no multiple tracking will be there. In this case, the extra facilities needs to not to be provided because the specifications are same on all the platforms, on any of the section or any of the station. Multiple tracks, yards, equipments of different specifications again are not required. In this case, it's going to cut off the cost which is there in terms of the multi-gauge conditions. Better transport infrastructure will come up with the uniform gauge policy with the provision of the same gauge throughout the country. Better and efficient movements will be there. Direct connectivity to different areas previously served by only meter gauge. Higher opportunities to masses. And of course, this is another important aspect as far as the economic conditions are concerned. It will boost the investors' confidence because there is no transshipment of the material. The long distance movement of the freight will be possible, and this is what we are seeing nowadays on the Indian Railways, where the Indian Railways are earning large amount of revenues because of the boosted investors' confidence by the provision of the long distance high speed freight trains or the container trains. Now, once we have completed all those aspects, the two specific aspects of the gauges, we will be looking at the 2 or 3 next slides, that is loading gauge and construction gauge. Now here in this diagram, a loading gauge has been shown. This loading gauge shows the dimensions in terms of there is a one L-shaped angle condition from which there is a suspended arm or arch. This arch is having certain height at the center as well as at the ends from the rail sections which have been provided here at the bottom. So this is the total amount of height which can be there of any loaded wagon. Similarly, this is going to be the total width of the section or the wagon which can be filled with any material. That is, in the case, mostly it is going to be used in the case of the freight transportation. This is very important because we have to look at the different specifications which have been provided to the Indian Railways, and the wagons have to comply with all those specifications. So therefore, this loading gauge represents the maximum height and width to which a rolling stock may be built or loaded. Now we can look at the specifications. In the case of the broad gauge, the maximum height is 4140 mm, whereas the width is 3250 mm. In the case of the meter gauge, though we are still continuing with the meter gauge, that's why we are looking at this aspect. The height here is 3455 mm and the width is 2745 mm. Then there is a construction gauge. Construction gauge is the gauge which is decided by adding necessary clearances to the loading gauge so that the vehicle can move safely without infringement. This is the condition which is to be provided in case of all the bridges or the tunnels or the pavements or the platforms which needs to be constructed or the shades about the platforms, because there are certain clearances which are added to the loading gauge, and then with those clearances this construction gauge is provided. Now today what we have discussed so far is the different types of the gauges and the specific gauges and the problems associated with those gauges and the way out by which those problems can be nullified. Now in this case, what we have seen is that the provision of uniform gauge policy can bring in the balanced growth in the country. At the same time, it can reduce the inconveniences for the passengers or for the shippers who are going to haul their freight from one point to the other point. So therefore, this is going to be a good condition as far as the Indian Railways is concerned. We are going to stop at this point, and in the future lecture we will be looking at the permanent way, the aspects related to the permanent way, the wheels and the locomotives and the associated features with that one, that is the coning of wheels. So students, we stop at this point. Have a nice day. Bye.